Hello everyone, welcome to my YouTube channel. In today's video, we are going to discuss about very important topic, that is dimensionality reduction and feature selection, which are very important but sometimes also confusing as well. So in this video, we are going to discuss about the techniques also. So let's firstly start with dimensionality reduction. So we know when we talk of machine learning classification problems, there are too many factors that are to be considered for before the doing the final classification. Like we have multiple attributes, we can call various features, call them attributes, features, properties, or whatever. Simply the name of the columns in case of normal data. So the higher the number of features or attributes, it is very difficult for us to decide which attributes to be chosen or which features are to be selected for training the data as a training data to train the model. So most of the features are correlated. We work on one of the technique, that is correlation. That is how two or more features are correlated to each other. And dimensional reduction is one of the process of reducing the number of random features under consideration. And one of the very best techniques that is used is known as selecting the principal variables, and we have technology methodology like principal component analysis. I will be uploading a separate video for principal component and analysis itself. So we know that this is a process, that is dimensionality reduction is a process of reducing, as its name suggests, it is a technique of reducing the number of random variables that are under consideration and can be divided into feature selection and feature extraction also. So dimensional reduction is the process of reducing the number of random variables that we are going to consider randomly and can be divided into the two main techniques, feature selection and feature extraction. Now suppose we have to check whether the email is spam or not. And for that we have features like generic title of the mail, content of the email, users, template or such methods. Based on that we have to decide whether the mail is spam or not. So in that case we have to pick few attributes from that. Similarly, we have a data set like temperature, humidity, rainfall. Based on that we have to take certain season. So we have to pick few attributes from that. We can't take all, because after a certain threshold value it will start leading toward the problem of overfitting. Now suppose let's consider one example. Suppose in methodology we are having total 100 attributes in a data set. We are assuming this, and suppose firstly we have taken two attributes. Then in the next testing we have taken 3 attributes, 4 attributes, 5 attributes, 10 attributes, suppose 20 attributes, so on. And at last we have taken 100 attributes. Now what I want to say over here is we say that if we consider more number of attributes, then the accuracy of the model will be high. Why so? Now suppose we say if you study hard or if you work more, if you do more and more study, then you will get good marks. This is a thing that is happening. But at the same time it also may happen that suppose you are studying till midnight and you have not put a break on your study. In that case you may fall sleepy in the exam. This may happen. Fine. And while you are training your mind with lots of books, lots and lots of books, there will be a limit of your mind, and at a particular time it will start breaking. You will not be able to give the best result, and if you don't take rest. Fine. So same thing is happening over here. We say if we train our model with more and more attributes, then accuracy will be high. But we also should remember one thing. There, just like a human being, there is a threshold or threshold value or limit. So while we are training with 2 attributes, it's fine. We are training with 4 attributes, it's fine. We have trained up to 10 attributes, it's fine. We have appoint training with 20 attributes, we have got very good accuracy. But it may happen when you keep on training the model, and we have trained the model with 50 attributes, then at that time accuracy may drop. And that problem is also known as overfitting, because we are doing the overtraining of the model. It should not happen, because after a limit our model will stop giving more accurate results. Our accuracy will start dropping in that case. So it should not happen. There is a threshold value, we have to put a limit on that case. Now suppose we have to pick those 20 attributes, that is picking the best features. So we are reducing the dimensions from 100 to 20 only. So this is how it works, and that is known as dimensionality reduction. So under dimensionality reduction, we have two parts: feature selection and feature extraction. Feature extraction is also known as scaling. So feature selection is basically a subset of the original set of values or features to get a smaller subset rather than taking all the attributes. And feature extraction is basically doing the scaling, which reduces the data in high dimensional space to a lower dimensional space. So feature selection is basically limiting the number of variables, and feature extraction or scaling is known as reducing the high dimensional space into the low dimensional space, which having lesser dimensionals. So let's discuss about feature selection more in detail. So higher dimensional data sets increase the time complexity, and also the space required will be more. All the features in the data set are not always useful. Now suppose you want to predict the result of a student, then in that case contact number is of no use. Fine, we the result of previous semesters, from which area he belongs to, what is his schooling, all those matters, but it doesn't matter at all that the contact number of student will decide the result. So that attribute is not worth, so that is a useless attribute. So in that case, those type of attributes that are not giving any valid result should be discarded. So that is what we are doing in dimensionality reduction. And in that case, feature selection, we will not select that element or attribute. So some may want to contribute no information at all, while some may contribute to similar information which other is providing. So selecting the optimal set of features will help us to reduce the space and time complexity, as well as it also increases the accuracy or purity of the classification or regression, or also they are considered in the clustering or association also. It plays role in each and every one. So these are called variable selection or the attribute selection. So feature selection can also be named as variable selection or the attribute selection. So task of selecting a set of relevant features for use in model construction. It is used to identify the remove indeed irrelevant and redundant attributes. And we have 4 approaches for performing feature selection, that is wrapped method, filter method, embedded method, hybrid method. So in feature selection, the very first is the wrapper method. So basically when we talk of wrapper method, it simply considers the selection of a set of features like as a search problem where different combinations are prepared, evaluated and compared to the other combinations. What does it mean over here? It means when we are talking of wrapper method, suppose I am having attribute A1, A2, A3, A4, A5. Now in wrap 1, we took the combination of A1, A2, A3 to predict Y. Then in wrap 2, we considered A3, A2, A4 to predict Y. In wrap 3, we picked A4 and A5 to predict Y. So now these are trying various combinations to predict certain values, and we will go with the best one which is giving the most highest accuracy. We will pick the that combination. So this is known as the wrapper method in this case. So which is a predictive model which is used to evaluate a combination of features and assign a score based on the model accuracy. Recursive feature elimination, best fit search, random hill climbing are some of the examples of the this wrapper method. And the next method in feature selection, is filter method. So filter method applies a statistical measure to assign a scoring to a feature. Features are ranked by a score either selected or rejected from the dataset. We take correlation coefficient scores or the chi-square techniques when we are talking of filter method. So in this case, in wrapper method, we take the random combination of all the attributes and pick the best combination. And in filter method, we assign certain score to each and every statistical measure to the coefficients, and based on that, we pick the best the function in that case. And then we have embedded method. So in embedded method, basically we in the applied learning algorithms, it determine the specificity of this approach. It selects a feature during the process of the training set. It finds the usefulness of the attributes. So in this case, the best example is decision tree. What happens in case of decision tree? We calculate the information gain of every attribute. Fine. Suppose we are having A1 to A10, 10 attributes. In that case, we will pick which of the attributes? We will pick those attributes that are having the highest information gain. So that is known as the one of the example of embedded method technique of feature selection, in which attribute chosen based on the strategy technique of information gain. And when we talk of hybrid method, it is nothing else. It is just a combination of filter and wrapper method, or we can also say embedded method can be there, which is used in as a hybrid approach. This approach first selects the possible optimal feature set of further tested by wrapper approach. It hence uses the advantages of both filter and wrapper approach. So let's have a quick review of all this. In case of wrapper method, we take the random combinations and pick the best combination of the attribute. And in case of filter method, we go with the correlation coefficients, or those what is the correlation between x and y, that is dependent and independent variables. So we pick those variables that are having good correlation. In feature selection, we have embedded method also, in which the example is of decision tree, in which we take the attribute based on the value of information gain. Hybrid is basically a combination of filter and wrapper based techniques. So we have few parameters that are there for feature selection, that is correlation, entropy or information gain, mutual information is there. So correlation we have already discussed. I have uploaded a separate video of correlation and covariance. So for correlation and covariance, you can go, you can watch those videos for understanding correlation. Entropy, about entropy we have discussed in decision trees, and I have also uploaded one separate video for entropy. You can watch that video on the channel. The mutual information is a new parameter that we'll discuss in this. So amount of uncertainty in x is due to the knowledge of y. So this is calculated by Ix of y in this way. So joint probability of function x and y, marginal probability, and then the marginal probability of y, and use this formula to calculate this value. So we calculated this value to know the amount of information shared about the class y of feature, mostly used for dimensionality reduction in supervised learning. And then the next, after feature selection, we have the next important parameter, that is the feature scaling. So feature scaling is a technique to standardize the independent variable, that is setting the dimensions, as we have done in the practical programs also. Once we are done with the training and testing part, we have selected the attributes dependent and independent x and y, and the next thing is we use that scaling function. Standard scalar function is used in Python, so that we know the role of that. So that is the role which is being played by, which is performing the role of feature selection, that function. So feature selection is basically a technique to make the standardization of the independent features present in the data, to a fixed range, putting them into in general terms, scaling is keeping different values on the same scale. So that is having this thing in same range. It is performed during the data pre-processing feature. So feature scaling algorithms will scale age, salary, BHK in fixed range, and then no feature can dominate the other. If the feature scaling is not done, then a machine learning algorithm tends to weigh greater values higher and consider smaller values as the lower values regardless of the unit values. So if we consider the data without feature scaling, classes are yes and no. So prediction of the class of new data point, the model calculates the distance of this point from the centroid of each class group. Finally, the data point will belong to that class and will be minimum to the centroid value. So let's consider the example of feature scaling. So if an algorithm is not using feature scaling method, it can consider the value of 3000 meter to be greater than 5 kilometers. So let's consider we are talking of 3000 meter. In a data set, suppose we in a column we have written the distance value. In distance we have written 3000 meter. So 3000 meter we know. So here we can see in this distance value, we know that this 3000 meters is equal to 3 kilometer, and the another value in this case is written as 5 kilometer. So they are on different representing the same thing but with different units. So in this case, if we normally consider 3005, it will consider that 3000 is greater than 5, but actually this 3000 meter is less than 5, because this is meter and this one is kilometer. So when we do perform feature scaling, all the units will be treated at the same level. So this will be considered as 5000 meter, or it will consider this as 3 kilometer or 5 kilometer. So in this case, it will provide the correct result. So this is the role of feature scaling. So we feature scaling will bring all the values to the same magnitudes and thus tackle this issue. So in this case of technique of feature scaling, we have min-max normalization and the standardization. So min-max is the technique that rescales a feature observations value with the distribution value between 0 and 1. Similarly, standardization is effective technique which rescales a feature value that is distribution to 0 mean value. So we have other methods of dimensional reduction like PCA, linear discriminant analysis, generalized discriminant analysis, and the most common used method is principal component analysis that we will discuss in the next video. So thanks for watching the video.